Today we're learning about more balanced forces. Now you know that balanced forces are forces that are equal in size but opposite in direction. And we've often shown balanced forces with an image like this: two people pushing on a box from opposite sides. Now both people are pushing with equal force, so the forces are equal in size, but they're pushing in opposite directions. And because they're pushing in opposite directions, the box will not move. Well, today we're going to learn about forces that often you cannot see forces happening. Sure, these two people are creating a balanced force, but there's actually another balanced force already happening here. You know about a force acting on this box. It's one that's pulling the box downward. It's the force of gravity. But the box isn't moving, and because the box is not moving, we can tell that the force must be balanced. There must be some force pushing in the opposite direction back up on the box. Well, it turns out there is a force, and it's a force coming from the floor. This may sound odd, but the floor is actually pushing up on the box and stopping it from falling. So the force of gravity and the force from the floor create a balanced force. Here's another example. Imagine you are hanging this ball from the ceiling. Well, you know there's a force pulling the ball downward. It's the force of gravity. But the ball isn't falling. It's not moving, so there must be a balanced force. There must be something pulling it back up. Well, what's pulling it up is a force from the rope. The rope is pulling up on the ball and causing it to not fall. Let's look at one of these together. Here is a stack of books sitting on top of a table, and we know there's a force pulling these books downward. What is that force called? Well, that is the force of gravity. But when these books are on top of the table, are they moving? No, the books are sitting still on top of the table. And if they're not moving, what do we know about the forces on them? Well, because the books are not falling or moving, we know they must be experiencing a balanced force. And remember that with balanced forces, they are equal in size, but they're opposite in direction. So there must be a force pushing up on these books. Where could the force pushing up on these books be coming from? The force is coming from the table. We see the table is touching the books and pushing them up so they don't fall down. Now it's time for you to try some on your own. Imagine that you have a rope attached to a wall. You have two people who are pulling this rope as hard as they can. They're putting in a really big pulling force. But no matter how hard they pull, the rope does not move. What type of force is acting on the rope, and what is causing it? Well, because the rope is not moving, you can tell it's experiencing a balanced force. That means there must be a force pulling in the opposite direction just as hard. Well, there are no other people pulling. What this force is coming from is the wall. The force is coming from the wall, which pulls back on the rope and stops it from moving. Here's one more example. Pretend you just bought this house and you want to hang a light bulb in front so you can see in the nighttime. What forces are acting on this light, and how can we describe them? Well, there's a force of gravity pulling the light bulb down, but the light bulb is not falling, and so it must be experiencing a balanced force. That means there's a force pulling it back upwards as well, and we can see that force is coming from the wire or that rope that's holding the light bulb up. The wire stops the light bulb from falling and ensures that it's a balanced force. So from today, remember, often you cannot see forces acting on objects, but they are still there.